There we go. Find the area of regular polygons. So what I did was I took the polygons and I circumscribed a circle around them. All right, so here's a quadrilateral and a pentagon and a hexagon and a heptagon and an octagon and a nonagon and a decagon and an utagon and a dodecagon. Can you see what's happening to the figure as we get more and more sides? Well, no, the angles are getting bigger. What do you think, Joyce? Yeah, isn't it getting to look more and more like a circle? If I had a million gone, what do you think it would look like? Yeah, to our eyes, like maybe if you put it under a microscope, you could see, but to our eyes, it would look just like a circle. And a circle is actually, like if you think about a circle, it's a figure with an infinite number of sides, right? It just has the sides are infinite, so it's rounded out to be a circle. And what I did was I cut each circle up into sections based on by drawing to the corners of the figure. So like this had 4 little sections, 5, 6, 7, 8, 9, 10. What's happening to those as I put those sections together? What's it starting to look like? A rectangle, isn't it? Like as we get more and more sides or more and more triangles together, is the curved part is becoming flatter and flatter, and it's looking more and more like a rectangle. So can you picture, like if I put a million of those smushed together, it would really look like a rectangle, right? So let's answer these kind of summary questions, review a little bit. So if we keep adding sides to these polygons, what shape will we get eventually? A circle, right? And if you keep stacking these pie pieces together, what shape will it eventually make? A rectangle. Okay? All right, so now think about this. In a million gone, what part of a circle would be equal to the height of the rectangle? The radius, wouldn't it? Can you see, this is like a pie piece, right? That goes like this and like this. So this side here is a radius. Does that make sense? So the height of my rectangle would be equal to the radius of the circle. Okay? And in a million gone, what part of the circle would be equal to the base of the rectangle? Okay? So the base here would equal what part of the circle? This one's a little trickier. Close. No, not the diameter. Think about, we took half the pie pieces and put them face down, right? And half the pie pieces face up. So these are just the face down pie pieces, right? So it's not the whole circumference, it's half of the circumference. Does that make sense? Do you see what I'm doing there? So it's half the circumference. Okay? Now, this is still that shape. I just cut it apart and rearranged it differently, but the area won't be different, right? The area of this shape is the same as the area of these pieces together. I haven't changed the area of it, I've just rearranged it. Okay? So in general, how do you find the area of a rectangle? Base times height. Thank you. Base times height. Okay? Now, let's put it in terms of the circle. What would the base be equal to? What do we say the base was equal to? Half the circumference, right? The base is half the circumference, and the height was the radius. Okay? Now, of course, you know, in math, they can never just let us use words that we've already used before or the ones we know in English. They have to make up new words. So the radius of a polygon, this that goes from the center of the polygon to the side, is called, the part that's the radius is called the apothem. Okay, so you'll see that word instead of radius. Okay, but it still goes from the center of the polygon out to the side. But instead of radius, we call it the apothem. And actually, over the years, it's kind of changed. Like if you get a really old professor in college, they'll say apothem. But nowadays, everyone says apothem. So don't be fooled if you go to college and they say apothem. Don't get freaked out. It's just an apothem. All right, and the circumference is for circles. What do we call it for any other polygon? Perimeter, right? Okay, so if we translate into our new words, the formula for the area of a regular n-gon is 1/2 perimeter times the apothem. Any polygon. N always stands for just an unknown number of sides. So it could be a pentagon, hexagon, heptagon, 30gon, whatever, just an n-gon. Okay? All right. So to find the area of any regular polygon, and what's regular again? I forgot to mention that. What is regular again? Right, all equal sides and equal angles, right. So any regular polygon, you take 1/2, multiply it by the perimeter, and then the apothem. Okay? All right, so there's two ways. Like the Common Core looks at the formula from the perspective of a circle. The old book looked at the area as a set of triangles. So I'm going to show you both ways, and whichever way makes sense to you, that's the way you should remember it, okay? So the old way, the old book used to teach it, it said anytime you've got a regular figure, you can divide it up into equal triangles, equal isosceles triangles, okay? So like a hexagon that has 6 sides would have how many triangles? 6, right? A heptagon would have 7, right? Okay, and if you find the area of one of these triangles, you could just take that area and multiply it by 6, right? And that would give you the same thing. All right, and I mean it ends up being the same thing because what do we call this? This height of this triangle is also the apothem, right? And if I find the base of this triangle and multiply it by 6, what's that? The perimeter. So really we're kind of doing the same thing, but it's just looking at it from a slightly different way. So whichever way you makes sense to you, you can do it that way. So we've got, and remember, the apothem is to the side. That's one thing that you got to be careful of. It's not to the corner, it's to the side. Okay, and So what we do to find the area is we're gonna make right triangles, because right triangles are our best friend, right? If we can find a right triangle, we have so many tools to find missing pieces. We have all the special right triangles, the 45, 45, 90, and all that. We have trig, we have Pythagorean theorem, we've got similar right triangles. We can use lots of different tools to find missing sides. So when I draw this altitude in here, it makes a right triangle, right? Do you see it right here? So I can use one of my tools to find the missing pieces, the apothem, the perimeter. All right. So there's three basic formulas. They have to tell you something about the figure, otherwise you can't calculate the area. So there's basically three things they can show you. They can show you the apothem, tell you how long the apothem is. They can tell you how long one of the sides is, or they can tell you how long the distance is from the center to one of the angles. Okay? That's basically the only three things they can show you. So we're going to work one of each kind of problem, and I would jot it down, and then tonight you'll have an example of all three kinds. I'm sorry? No. Tell like you don't know that. All right. So in this case, what did they give us? The apothem. Okay? So to find the perimeter, we're going to make a right triangle. So what I'm going to do is make one of my isosceles triangles. Okay? And this is a hexagon, right? 6 sides. So how many triangles are in here? How many identical triangles? 6. Okay? So if I went all the way around, how many degrees would it be all the way around? 360. So if I'm dividing that 360 degrees into 6 equal pieces, how could I find out what one piece is? Yeah, exactly. 360 divided by 6. Okay? If this were a heptagon with 7 sides, I'd do 360 divided by 7. If it was an octagon, I'd do 360 divided by 8, right? And that's going to give me the measure of any one of those triangles that make up the whole shape. Okay? So 360 divided by 6 is 60 degrees. So each one of these triangles is 60 degrees. That's 60, that's 60, this one's 60, right? But to get that right triangle, I had to put in my altitude. So I divided, remember now it's an altitude, it's an apothem, it's a angle bisector, it's a perpendicular bisector. Like, remember, they're everything. So I bisected this angle, so how much is each side? 30. Okay? So in a hexagon, the two sides are 30s, and if this is 30, what's this one? 60, because it has to equal 90, right? So that one's 60, 30, 60, 90. So I can do it two ways. I can use my 30, 60, 90 triangle, or I can use trig. Which way do you guys want to do it? Trig? 30, 60, 90. That would be my choice, but we'll do trig. All right. So I'm looking for this piece here, right? Because my formula is 1/2 times apothem times perimeter. So my apothem I know is 14, so I'm looking for the perimeter. So if I find this little piece, I can multiply it and get the whole perimeter. So if I have this side and I'm looking for this side, from the 30-degree angle, which trig function is it? Tangent, right? Opposite over adjacent. Everybody following me? We got it? Okay. So let me do this. So I'm going to use the tangent of 30 degrees equals opposite, which is x, over adjacent, which is 14. All right. Then I multiply both sides by 14. The x isn't on the bottom, so I don't have to worry about that. And 14 times tangent of 30 is, I don't think that's it. 14 times, make sure you don't do tangent of 30 times 14, because that'll give you the tangent of 300 and whatever, 400 and something. 8, yep. Did you get it to work? To check mode, make sure you got it on degrees, not radians. Okay. All right, so this little piece here is 8.08. How many of those little pieces are there all the way around here? 12, good. There's 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 altogether. So I'm going to take this 8.08 and multiply it by 12, and that gives me 96.96. All right, so my perimeter is 96.96. So if I multiply 1/2 times 14 times 96.96, I should get 678.96. Why would I multiply? It's because remember the formula is 1/2 times apothem times perimeter. So I did all that work to find the perimeter. So once I found it, then I could plug it into the 1/2 times apothem times perimeter. Exactly, exactly. Because you found this piece, right? And how many of those are there per triangle? 2, right? 1, 2. And how many triangles are there? No, no. It's the half came in here. Yeah, yeah, yeah. You could leave that half out and just do half the perimeter, but when it gets to be like heptagons and stuff, it gets too confusing. So I would leave that half there and find the whole perimeter. Yeah. Doesn't matter. Multiplication's commutative. So you could do 1/2 times perimeter times apothem, or 1/2 apothem times perimeter, and you'll get the same answer. All right? Yes. So in this one, first of all, what kind of shape is it? It's an octagon. What piece did they give me? One side. So what am I going to be able to calculate from that? The perimeter. So my formula is still going to be 1/2 times apothem times perimeter, but my perimeter is going to be the part that I have. So if this side's 12, and how many sides are there? 8. So 12 times 8, 96. So my perimeter is 96. Now I need to calculate my apothem. So what I do is I create my triangle again. Oops, that didn't look very good. Right to the center and out to the corner. That looks worse, so well. All right, and how many triangles are there? 8. So how would I figure out that center angle? Divide by 8. 360 divided by 8, which is 45. So each of these angles is 45. And I draw in my apothem. Wow, I'm having trouble with straight lines today. So each side would be what? 22 and a half? Good. And each piece of this side would be 6 and 6, right? Okay. And if you don't like to have the x on the bottom of the fraction, like if you don't want to solve that way, you can also figure out this angle, because if that's 22 and a half, 22 and a half minus 90 would be what, 67 and a half? So you could find that angle and use that too if you want. The height. This, 45? That's an angle. That's that angle. It's half of 45. Yeah. Okay. All right. So I'm looking for the apothem. I have this side. So which trig function? Tangent. So I would do the tangent of 22.5 equals opposite over adjacent. I have x on the bottom. Bummer. So I got to multiply, get rid of it. Those cancel. And I get x times tangent of 22.5 equals 6. And how do I solve for x? Divide by tangent of 22.5. And so what's the length of my apothem? 13.6? 14.6. Can you do 2 decimals? 14.63. Okay? And then all that work to find the area. So now I multiply those together to get the area. And it should come out to approximately 695.3. Okay? Questions? So the most difficult one is when they don't give you the apothem or the perimeter, and you got to find both. And unfortunately, it's also the one with the most rounding usually because you have to round both of them. All right? Any questions?